Number 17, evaluate the integral x squared quantity x cubed plus 5 to the 6th dx. All right, on this one I do notice that I have parentheses, so I am going to be using a u substitution. I am going to let u equal x cubed plus 5 because that is what's in parentheses. I am then going to list du, which is the derivative of x cubed plus 5. The derivative of x cubed plus 5 is 3x squared dx. Now I just need to make sure that all my parts are there. I notice that this says 3x squared, this only says x squared, so I'm going to put a 3 on the inside, which means to undo it I'm going to put a 1/3 on the outside. So now let's write what we have. We have a 1/3 and then we have an integral sign. Okay, I'm going to cross this off and that becomes u. So I have u to the 6th. And then if the 3x squared and the dx together become du. So now I'm all set to work this problem. I have 1/3. The integral of u to the 6th would be 1/7 u to the 7th. And now I am going to go ahead and multiply 1/3 times 1/7 is 1/21st. And I'm just going to replace my u back into the problem. And then plus c, and I am done. Okay, problem 18, evaluate the integral of cosine 8x from pi over 16 to pi over 8. Again, I'm going to use a u substitution because if I were going to type this into my calculator, I would have parentheses right here. So I am going to let u equal 8x. If I take the derivative of 8x, I'll get 8 dx. I notice that I do not have an 8 in the inside of my problem, so I'm going to put an 8 on the inside. To undo it, I will put a 1/8 on the outside. So now let's look at what we have. We have a 1/8. And then we have, cross this 8x off, we called that u. We're going to, the 8 and the dx together become du. So if I look at this, I've done nothing with the cosine. So the cosine's still there, but now I just have u and du. All right, so from here, I know the integral of the cosine of u is sine u. So this is going to be 1/8 sine u. Okay, one thing else that I'm going to do that I showed you early on an earlier problem was if we have pi over 8, let's change it to a u value, and pi over 16, let's also change it to a u value. So here, u, if I plug pi over 8 up here, 8 times pi over 8 is pi. And then if I plug pi over 6 up into my u, 8 times pi over 6 is pi over 2. So at this step, I really could have made it pi over, there we go. Now when I go to evaluate it, I can just evaluate at pi and pi over 2. So now if I plug it in, I'm going to get 1/8 sine pi minus 1/8 sine of pi over 2. I do not get to use my calculator, so I have to know those. I'm going to draw myself a unit circle. First of all, I need the sine of pi. Pi is over here. The coordinates over here are -1, 0. I know the sine is a y value, so the y value at pi is 0. So this whole problem will just be 0. And then the sine of pi over 2 is right up here. That point is 0, 1. The sine is the y value, so the y value is 1, so it's going to be 1/8 times 1. 0 minus 1/8 times 1 is -1/8. Okay, if you had not done this step that I did, you would have ended up having 1/8 sine of 8x, and then you would have been evaluating it at pi over 8 and pi over 16. We would have plugged the pi over 8 in, and notice when I do that, 8 times pi over 8 is pi. And then when I plug pi over 16 in, 8 times pi over 16 is pi over 2. So you end up getting the same thing, just two different approaches. All right, problem 19, evaluate the integral tangent to the 4th x secant squared x dx. I know that I'm going to have to use a u substitution on this one because there's really no other way around it, but it's figuring out what u is going to be. I know that the derivative of tangent is secant squared, so I'm going to let tangent of x be my u. I'm not going to consider the 4th power right now, just u. The derivative of tangent is secant squared x dx. And I notice that I have that, so I'm not missing anything. So if I go to rewrite this, okay, tangent x was u. So I still have the 4 in there, so it's u to the 4th. And then secant squared x dx gets crossed out because that became the du. This now becomes a very simple problem to solve. The integral of u to the 4th is 1/5 u to the 5th. And now I just need to put my u back in. So I'll have 1/5 tangent to the 5th x plus c, and I am done.